Okay, so we got a quick one here. It's linear versus non-linear. And we're going to look at three different ways: a graph, equation, and a table of values. So in a graph, very easy to see. A line is linear. Anything that's not a line is non-linear. So this first graph here, we have a curve. So that would be non-linear, whereas the line would be linear. Easy enough. So if we have a graph and we see that it's a line, then it's linear. That's the question you're asking yourself. Next is if you have an equation, you look at the degree. What's the degree of the equation? And it's the highest exponent when it's in standard forms, no brackets when it's expanded out. So if it's degree 1, then it is linear. So what's the highest? This is in standard form for A. Everything's expanded out. What's the highest exponent? Don't see it, but there's ones there. So that's degree 1. So linear. For B, again, you don't see them, but it's degree 1. We can tell it's in y equals mx plus b form that we've seen before. We know the slope and the y-intercept and all that, so it's linear. Degree 1 must be linear. Now, for C, the thing is it's not in standard form. So if I expand it out, I get 2x squared minus 8x. So now we see that the highest exponent is 2. That's degree 2, which means nonlinear. And finally, the last one, we see the highest exponent is 4. So it's nonlinear. Okay, so degree 1, linear. So if you see, look here, what's the degree of the equation? X, if that's what you see, x, you don't see x squared or x cubed or x to the power 4 or anything else, that means it's linear. So far we've covered the graph and an equation. So graph, it's a line, equation, degree 1. If it's a table of values, what we're looking for are that the first differences are constant. So let's see. Table of values. If we calculate our first differences, and remember what you're doing is taking the second value and subtracting the first one. So 25 minus 9 is 16. 41 minus 25, also 16. And 16, right, all the way down. So that means it's linear. The first differences are constant, the first differences are the same, so it's linear. Let's look at B. 16 minus 0 is obviously 16, but 25 minus 16 is 9. So first differences are not the same. We could keep calculating, but we already know it's non-linear. Okay, I'll leave the other one up to you, but as soon as your first differences are not equal, then we have something that's non-linear. If they're the same, then they're linear. So 3 different ways: equation, graph, and table of values. Okay, and it's all summarized